Hey everyone, my name is Nathan Peck. I work as a developer advocate at AWS. And one of the things I really like to focus on is developer experience. I come from a startup background, working with very small teams, typically trying to build big products and big ideas. And so one of the things I'm very passionate about is enabling developers to be able to build things faster and more easily. And I think the containers are a very large part of that. So you've seen over the last couple of sessions an overview of the type of services and the thinking behind the container services that AWS is developing. Now what I want to do is I want to show you a little bit about what the developer experience looks like and what some of those tools are that we're creating to make it easier for developers to start out using containers on AWS. So the first thing I'm going to start out with here is the command line, because that's generally where a lot of developers are comfortable spending time day to day. And the first tool I want to show is Copilot. So Copilot is a command line tool, which, as you could kind of determine from the name, is designed to be your partner as you're setting off on this journey, this flight, if you will, of taking your application from your developer laptop up to a production environment. So the first command I want to show is Copilot Docs. We're going to open up the documentation site here, get a little idea of what Copilot is and what it can do for us. And the tagline here is basically the message that I want to get across about Copilot, which is that Copilot is your toolkit for containerized applications on AWS. And you'll notice we're focusing on several different stages of your application's lifecycle. The build stage, this is where I have my code on my machine, and I want to actually create that container artifact now. This is something where a lot of people, when they're first starting out with containers, they have a little trouble there. They realize that there's a lot of repetitive things they have to do in terms of typing out Docker build, Docker push commands. And that's something where we can automate that. We can make that easier. Then there's release. One of the things that we've seen at scale is that every organization, as they're developing containers, they quickly reach the point where they say, I want to automate my releases. I don't want to have to call the Kubernetes API or the ECS API or Fargate API or any of these other APIs manually, or even click around in a web console every time I want to release my application. I want some way to automate the releases of my application. And then the final stage is operation. This is, we've gone through the process of building, we've released to production. Now we want to monitor and make sure that this thing is working properly and have the ability to scale it up and down and make sure that this really keeps running for the foreseeable future. So the documentation site team has done a fantastic job putting it together. I highly recommend checking this out if you would like to learn a little bit more about Copilot after this session. But for now, I'll transition back over to the command line, and we'll start taking a look at some of the commands that we can actually use in Copilot to release a containerized application. So to do that, I'm going to bring up my Visual Studio Code here. And first, I'll spend a little time to introduce the application I'll be deploying today for us. So this application is a simple hit counter. The idea behind it is anytime a request comes in, we increment a counter inside a DynamoDB table, and then we return the total number of hits to the service, and then the host name of the particular container that's actually serving this request. So it's not a super complicated application, but I think it does a good job of expressing the type of application that many people choose to deploy using containers. Something that's a fairly simple API, and most likely if they're developing a modern application, they're developing in a stateless manner. It's not storing state locally. It's instead using an external service, external database, managed database most likely, to store the information and state for the application. So that's what we have here. We have a container. We want to expose it directly to the public via a load balancer, and we want to store some state in a database which is attached to this particular service. So we'll see how Copilot helps out with this. So the first command to learn with Copilot, let me make sure I'm in the right folder here. Yeah, I'm in the folder with my application here, and you can see if I look at my application, all I've started out with providing for this application is the application code itself and a Docker file. So if I look at this Docker file, I did have to write this Docker file myself, but it wasn't a super complicated Docker file. All I had to do was install my dependencies, such as Node.js and packages, and then I specified the name of my application code file, said to run it with Node, and then I added the little statement here saying expose 80, which says this is an application that listens on port 80 for traffic. So believe it or not, this is all I really need to get started with Copilot. So the first command I'm going to use is called Copilot Init. And this is intended to be the first thing that you do with Copilot. It's going to pop up a wizard that kind of walks you through the process and asks you interactive questions about what type of service you're trying to deploy. So the first question it asks me is what service type best represents your services architecture? And I have two options here today, backend service and load balanced web service. So a backend service is designed for something that's sort of internal. It's a service like maybe a password storage service or something that is used by one of my other services, but it's not technically used by my customers. In this case, because I'm building a hit counter application, I probably want to call that directly from a client or directly from a website. I'm going to choose load balance service because it's public facing. And I choose a name for the service. I'm going to type out hit counter. And then Copilot has actually explored my application directory and found the Docker file that describes my application. It's already pre-filled that for me. It says, which Docker file would you like to use? There was only one Docker file here in this case. If there had been multiple, it would prompt me which one I wanted to deploy. In this case, I'm just going to press enter because it's already found the single Docker file for my application. And we'll see it kicks off the process of creating infrastructure to manage services for my hit counter application. And after it does that, it says, all right, you're all set up for local development. Would you like to deploy a test environment? So this is going to actually initiate a deploy to AWS Fargate on AWS. And so I'm going to say yes. And just like that, it's that simple. We are already setting up a test environment. We're linking the account to my application, and we're going to start deploying an application. So this is going to take a couple minutes. Most of the time is spent on things such as load balancers and load balancer health checks. You'll see it's already started the process of building my Docker container, pushing it automatically, and now we're waiting on deployment. While that is taking place, I'm going to pop this over to the side, and I'll show you how you actually configure an application in Copilot by showing the manifest for my application. So we talked a lot about YAML, and YAML is a fantastic format. We actually use YAML for Copilot as well. But what we've provided with Copilot is a more simplified YAML format for defining your application. And you'll see that we've stripped everything down to the most basic configurations that are required for most applications. There's a lot of types of configuration that you don't necessarily need to use for every application. We've tried to target for Copilot the core set of functionality that you'll probably want to modify, such as your port, the path for your health check, the amount of CPU and memory, and how many containers to deploy. And then there's a few extra alternative settings as well for, for example, log level environment variables. You can specify multiple environments and different counts and sizes of containers in each environment. But this is a simple starter application here. If you think about it, there's a lot of applications that this is all you really need to configure. However, we know this application is a little bit more complicated. We need to attach a DynamoDB table here. And so you might start to think, okay, well, I don't see any configuration for that. Well, we have a commands for storage as well. So I'll take a moment at this point to show the list of commands that Copilot provides. And you'll see it is very similar to those lists of things where we said build, release, and operate. Well, here we see develop and release. And you'll notice under add-ons, we have something called storage, commands for working with storage and databases. So this is a fantastic feature of Copilot that I really like. So I'm gonna type Copilot storage and press enter, and it gives me, it says a little helpful prompt there. It says I need to type init, which I forgot the first time. So I'm gonna say Copilot storage init. And so you'll see what it does is it asks me what type of storage I'd like to associate with my hit counter application. So I'm going to choose DynamoDB table, and I can now have an option to name the DynamoDB table and choose a primary key. Now, just for the sake of time, I've already gone through and filled this out previously, so I won't go through this whole wizard here, but I think you get the idea that this is going to interactively prompt me to ask questions about what type of table I'd like to create, what my primary key is, and it's going to actually create that table for me. You can see that this table that it defines is actually a standard CloudFormation template, which, if you're familiar with CloudFormation, is very, very standard stuff. And what it does is it simply creates the table, and it creates a IAM policy. Where's the IAM policy? This is IAM policy right here, which allows the application to actually modify and write to the table. And then here's the definition of the table itself. So once this has been defined here, when I deploy my application, it will automatically deploy that table as well and create the associated environment variables that my code can use to actually reference that table. So we've already done that. Now I can start to explore my environment and look at the type of applications on my remote test environment now. So I'm going to type Copilot service show, and it lists out only one service that it found here called the hit counter application, a type, load balancer web service. I see some high-level information here. Because this is a test environment, I'm only deploying one of them, and I'm deploying a fairly small one that'll be very cheap. It's a quarter of a CPU and 512 megabytes of memory. But most importantly here, I can see that there's a public URL for my application. And if I command click to follow this link, I can open this up in my browser, and here's my application here. And you can see it's been counting hits for a little while. Because I had created this DynamoDB table last night for the demo, it's already accumulated 41,000 hits here. And if you pay attention closely, you might notice that it's going up by 2 every time I refresh. Well, that's just because Chrome sends 2 requests, one for the favicon and one for the actual HTML page here. So that's the reason why it's going up by 2 hits each time I refresh. But here we go. This was actually very simple. We were able to go from Docker container to adding a DynamoDB table to deploying that in the cloud on AWS Fargate with just a few commands. And Copilot isn't done yet. If I want to, I can also, if I look back in my Copilot, you can see commands for service. So I want to dig a little bit more into those Copilot service commands. And you can see that one of them here is Copilot service logs. So I want to actually look at the logs for my service. And once again, it found my service. And I'm able to look at logs here and see that at some point in the past, it's highlighted that there was an error here. This was previously last night when I was experimenting with and writing the code for this application. And so I'm able to see this and tail these logs actually. It's designed not only to help you get up and running initially, but also to monitor and work with your service going forward. So I can also do service status as well, which will evaluate the health of my service and let me know, for example, okay, what image am I running? What's its health status? And if there was a failure or a stop for some reason, here in this case, alarms, it'll tell me the reason for that alarm as well. So we're doing a lot of work to make it something that feels intuitive, commands that they make good choices. They find the service that I'm deploying, they find the Docker file, they prompt me with choices that make sense. I don't have to guess. I don't even have to really, to be honest, look at the documentation that often because Copilot understands what I'm trying to do and provides suggestions for what I'm trying to do. So as a starter experience, Copilot is fantastic. Some of you may be starting to think, though, what about if I have a more advanced application, has a lot of different components, maybe it has some things that it requires some configuration that Copilot doesn't support out of the box. Let's say, like you might have noticed that I didn't really see anything in here in these Copilot manifests about GPU support. So if I was trying to run a machine learning workload, that might not be ideal. Well, I want to show the next sort of higher level, or I would say like higher, it's another parallel abstraction that provides a little bit more control over your application. And that's AWS CDK. So AWS CDK is stands for Cloud Development Kit, and it's an SDK for defining your application programmatically using your favorite programming language. Massimo introduced this a bit earlier. One of the things I'll start out with, once again, the same thing I like to do for Copilot. I'm going to type CDK Docs to open up the CDK documentation. And really to show you an idea of like the extent of this Cloud Development Kit, if I open up the API reference here, you can see pretty much every AWS service has a module within Cloud Development Kit for working with it. And most importantly for this particular demo is Amazon AWS ECS. So you might have seen earlier in the presentation the idea that Fargate isn't something that you interact with directly. It doesn't have its own API. Instead, you work with Fargate through either the Amazon ECS API or the AWS EKS API. So that's what you're seeing here. Basically, this ECS module is providing code abstractions that allow you to create resources on your AWS account using a programming language that's familiar to you. In this case, this is TypeScript, JavaScript. And you'll see that it's very easy to create a cluster, add EC2 capacity to it. And then we're creating an EC2 task definition, adding a container to it, and then launching that container as a service inside of this cluster on that EC2 capacity that we add to the cluster. And you can kind of get the idea that this is very few lines of TypeScript code here, but it's doing a lot. It's accomplishing a lot of things. And it actually becomes even easier when we scroll down and we look at, for example, Fargate example. Where is it? Down here. I lost it now. Aha, yeah, Fargate service. So Fargate service is actually even easier to define because when it comes to that cluster, we don't have to even create any EC2 capacity inside of that cluster. So this is sort of the first level of CDK that I want to present. There's multiple levels of CDK, though. One of the advantages of defining your infrastructure as code using a programming language, such as JavaScript or Python or whatever it is that you're choosing to use, is that you can start to build these smarter and smarter tools on top of your infrastructure as code that understand your intent and understand what you're trying to create. And so one of the things I want to show today that we recently launched is AWS ECS Service Extensions. I'll just show the code for that because it's a little bit easier to understand. So the idea with ECS Service Extensions is that it allows you to programmatically create your own extensions or use built-in extensions that add features to your service. And some of these features can be very, very complex. The thing I'm going to start out with first is showing the ECS Service Extensions for that very same hit counter application that I had already deployed using Copilot. And I'll show you what that looks like when I define this using CDK. So I start out by saying, here's a new application and a stack that I want to deploy. This stack maps over to a CloudFormation stack, which is basically just naming the stack that I would like to deploy my infrastructure to. And then the first construct I want to introduce is the idea of an environment. I just showed in Copilot, there was also the idea of an environment. We created the test environment to deploy. And then the first thing we do is we create a service description. And that service description is basically a wrapper for what is my service I'm trying to create and what type of features do I want to attach to that service. So the first thing I add to the service description is a container. Once again, there's a very minimal configuration API here to just add the container. I'm just adding my image, my traffic port, memory, and CPU. There are other options as well that I'm not utilizing in this code example. For example, I can specify environment variable. But all of these things are extendable too with your own extensions, which I'll show in the future. So here is one of the first extensions that I'm adding that we didn't really see demoed in Copilot, and that's the idea of a scale on CPU utilization extension. And so what this CPU utilization extension is going to do is it's going to monitor the CPU utilization of my application and auto scale it within certain parameters I defined. And here I'm saying that I want my initial task count to be 2 and the minimum task count to be 2. And I'm using the default configuration for example, what my CPU threshold should be, which is going to shoot for roughly 50% CPU utilization. And then the max as well, which is defaults to 10. And then once again, I need a DynamoDB table for this application. And so you'll see here that I've attached the extension for DynamoDB table here. And I name the table hits, and I specify my key for the application to do lookups. Then I want a load balancer, so I attach an HTTP load balancer extension to my service, and I instantiate that service into an environment by specifying the environment that I created earlier and specifying that service description that I have compiled here for out of these different extensions. So one of the things that's cool about this extension model is that it's plug and play, and you can add and remove as many extensions as you want. So this is just a very small subset of the overall available extensions. But if I go ahead and open up NPM and look at the ECS service extensions on NPM, you'll see that there's extensions for a variety of different services, such as AWS X-Ray for tracing your application, CloudWatch Agent for capturing metrics about your tasks, AppMesh for putting your application to a service mesh, Application Load Balancer, this is the HTTP Load Balancer extension that I was showing earlier. FireLens, this is a very cool one, which is a sidecar that attaches beside your application and enhances filters and routes your application logs. So it allows me to do stuff like identify which log lines came from this specific version of my application. Or it allows me to say, I would like to send my 500 errors, 5xx server errors to one particular log group that I have alarms and monitoring and pages my developers. And I want to send the regular 200s to another cheaper storage warehouse, basically, because I want to have a log of those requests, but I don't necessarily want to take action on them. And then we also have community extensions. This is people from the community who have started to contribute to these extensions. So here's one that someone has provided a more advanced application listener rule extension that allows you to really have one application load balancer and mount multiple services on different paths or different host names. This is an interface for working with your ECS services in a way that, once again, as I show the example here, is extremely easy to get started with. You can just attach an extension by saying mydescription.add and then the name of the extension, and you've just enabled that particular feature on your service that gets deployed. But one of the true powers of it is when it comes to creating your own custom service extension. And so basically, the service extension is a class, which once again, if you're a programmer who likes to work with code, you're going to be very familiar with the idea of creating a class and extending a pre-existing class and implementing the methods within that class. So I can extend the existing service extension class and implement methods that modify the service properties, utilize the service to call methods on it, or in other ways, mutate the service that's going to be created. And so I can create my own custom service extension that does whatever type of configuration that I want. And to explain the power of that, imagine a company where you have, for example, a operations team or a platform team that's responsible for creating the underlying platform. And then you have, let's say, 10, 20, 30 different service teams that are responsible for different components of your overall company. Oftentimes, what ends up happening with, especially with infrastructure as code, is you have each of those teams re-implementing from scratch different portions of the overall infrastructure and configuration. And then when you do want to make sort of a global change to something that you want to affect across all your services, it's a real job hunting them down, going through every single service and updating configuration across all these different things. This is a problem you see prop up a lot, especially with, I'm starting to see more and more tools for Kubernetes to solve this problem, because you start to realize that, okay, I have 100, 200 different unique Kubernetes manifests for different services, and all of them have some shared configuration and then some unique configuration. And then when it comes time to change something, we need to go through and start editing all of these things. And so people end up building out their own custom frameworks for essentially generating the YAML that goes into Kubernetes or it goes into CloudFormation. Well, CDK already exists and has this idea now for ECS of reusable extensions that you can share between teams. So for example, here I've created my own custom auto-scaling extension, and I can now distribute that to every team in the company. And we can say, let's start using the My Company custom auto-scaling extension across all of our services. Now, because it's centrally owned and centrally managed, if I update a property inside of this and modify how it works, then we're able to easily distribute that and roll it out. And everyone who has used this method of add to say my service description at add my custom auto-scaling policy is going to get that update. So this is a super powerful, I think this is a good example of how exactly CDK is so powerful for interacting with infrastructure as code.
Hey, Nathan.
Yes.
Can I jump on your soapbox with you for a second?
Yeah, go for it. Go for it.
I knew you wanted to go there. So I'm just gonna, because I know you probably want a little bit of feedback, but like I said, I wanted to jump on the soapbox with you for a second. I think you hit on an important part. Is this is a big problem. What you're talking about is a huge problem, and I know a lot of people that talk about they want to get into coding and all these things and all these different pillars and silos and all the things. What you hit on is very important, right? Mm-hmm. Is that because there's this huge disconnect across these different disciplines, being on a common path is paramount.
Oh yeah.
And like I say, I just wanted to echo what you were saying, because I could tell you probably wanted to get on a soapbox, but I wanted to jump up there with you real quick.
Oh yeah, so. I could rant on this all day.
Oh, trust me.
But
yeah. So, but like I said, I just wanted to throw that out there real quick. You're not alone, my man.
Oh yeah, for sure. And I think one of the things I really love about what the ECS developer experience team has been doing is we're doing that work to empower developers and give them the tools that they need. So that way you really go from this sort of siloed operations team and siloed application developer team and sort of bridge that gap. Yep. And you create a common tool with AWS CDK that operations can use to make their life easier, but then developers can also use to make their life easier.
Yep, absolutely.
So before we run out of time, I want to show what CDK looks like on the command line real quick. So the first command that I want to show is the diff command, because I think this it looks really good, and it kind of expresses the power of CDK in a nice way. So here I showed you this these lines of code here. It comes out to 52 lines of code, including white space and comments and everything like that. So it's fairly concise. I also, I could make this much more concise. It could probably get down to like 20 lines of code. When I type CDK diff, it's going to show me a preview of all the things that CDK is going to do on my behalf based on the SDK calls that I made. So it's showing me a preview of IAM statement changes. So this is like for the IAM role for my application, what things it's going to authorize. So you can see here it's authorizing the communications to this DynamoDB table. And you can see a list of all the resources that are being created. This is a pretty extensive list. It's definitely shorter than it would be with a lot of other platforms. Like if I was using EC2, if I was deploying on EC2, I would have auto scaling groups in here and EC2 instances and profiles and stuff like that. So this is still fairly simple because I'm using Fargate. You'll notice there's a lot of stuff that normally I wouldn't want to touch by hand. All the stuff relating to like networking has been automated away for me, and it's all hidden away behind this simple command here of new environment. Just by saying I want a new environment, this environment has been defined to be a certain type of networking environment, which can be controlled by, once again, by an operations team if they want to. As a developer, I can just use this new environment and it will automatically create all of those networking resources for me. And then different things that I've created, such as the DynamoDB table and the load balancer, we see attached here and created automatically as resources. So hopefully we have time for, I'll change this name real quick here. I'll show you what a deploy looks like here. So if I deploy this, whoops, npm run scripts. So by typing npm here, if you're familiar with Node, you know that npm is one of the ways that developers generally interact with their Node.js applications. And so once again, CDK is integrated tightly into my developer workflow. As a developer, the same command that I use to maybe launch my application or test it locally on my machine, I can now use to deploy it remotely onto AWS. And so here, what we'll see here is that once again, this output should look very familiar from when we were working with Copilot. It's the same type of thing. It's building and pushing my application automatically. I didn't have to type out a bunch of Docker commands to actually initiate that build and tag it and then push it to the cloud. It's done that automatically for me. And then we start to see a progress bar here and a CloudFormation output showing me the resources that it's modifying on my AWS account on my behalf. And once again, this is something that takes a little bit of time. So to make it a little bit less boring, what I can do is I can go into my account here, and I'll show you what it's actually doing on my behalf if I look at the CloudFormation. So this is something that I really like. So you can see the update in progress. This is the stack that's being deployed. If I look at, where is it, template, we'll start to get an idea of just how much configuration Aws CDK has done on my behalf based on the CDK commands that I entered in my code file there. This is all YAML that I did not actually have to type out. Basically, there's a lot of sensible same defaults that we can use out of the box, and there's ways that we can abstract away the meaning behind something like an environment and standardize what an environment means and standardize what for example, load balanced application means, such that I don't have to be so explicit and list out everything that I'm interacting with in terms of the configuration. But I still have that underlying power. If I want to, I can create a custom extension that modifies any one of these more complex settings directly if I wanted to. So it's designed to really scale with you. I can start out with a basic level of understanding and start out with the beginner commands such as Copilot and the basic usage of AWS CDK. And then later, as my needs grow and I get more and more complicated applications that I want to develop, I can start to create my own custom extensions or modify settings. And then later, even later on, as I work at a massive company that has many distributed teams, we can start to share some of these extensions internally, which is what you'll see here on NPM. All these things that we're interacting with on CDK are actually NPM extensions that have been created either by AWS engineers or created by or contributed to by individuals of the community who have created patterns and common configurations for what has worked for them before in production. And they're sharing that and collaborating with that on NPM. I'm really excited about this future prospect of not having everyone needing to reinvent the wheel and start from the beginning all over again. I can start working on an application and benefit from patterns, extensions, and really infrastructure that other people have utilized with success before in the past, and know that I'm working on something that is a platform that's really production ready. So here, once again, I have a CDK has given me a URL for my application. So I go back over here to load it up. And once again, we see a hit counter application, which is counting up the number of hits that has been hit to it. So there's a lot of hits from the load balancer, obviously, and I left this running, this particular table running overnight. So we're going to see a lot of hits on this. But hopefully this serves as a basic introduction to what the developer experience looks like of working with containers, and the power that the infrastructure as code frameworks provide. So
I have one real fast question. From the patterns and extensions perspective, and some of the things that you're seeing submitted in there, are you seeing from the regulatory and compliance perspective, like, so a lot of our customers have, compliance regulations and stuff like that. Are you seeing that these extensions are, I mean, obviously you'd have to vet it to make sure that it meets your needs, but what are you seeing in the wild?
Yeah, so there's multiple aspects to this. The first aspect that I want to mention is that a lot of these the patterns, particularly the extension that I just showed you today, have to go through like an AppSec approval process within AWS. So we are going through and rigorously going through all the IAM permissions, security groups, networking related things. So we put a lot of effort into making sure that these are secure by default. Now, the second aspect with regard to compliance that I think is more interesting, and we haven't fully developed this yet, but it's coming down the roadmap, is the ability to have third-party extensions that add third-party tools. For example, I'm actually very interested in investigating something like Twistlock or similar third-party vendors that provide this layer of runtime security that detects when something is out of the ordinary with what your application is doing. So I'm particularly interested in like Sysdig, Twistlock, and I think the idea is initially we're going to develop some of these extensions and distribute them. Hopefully we'll start to see more and more vendors creating their own extensions for ECS using this particular CDK model, or contributing to their own extension that we have created. But just in the same way that it's very easy to attach AppMesh or a load balancer to your service, it'll be very easy to attach some of the security monitoring and compliance tools to your application as well.
So you answered what my follow-up was going to be, because my next one was going to be, okay, compliance means so many things to so many people. What are you doing to then prove that? Where's the proof in the pudding?
Yeah.
Cool. Awesome. Thanks.
And I'd like to piggyback on that real quick too. I want to say two things, and I'll say them quick to give others opportunity to speak up. Is what you're describing from like the people contributing to this project and things reminds me of like Terraform modules and things like that. So it makes a lot of sense. The other part that I wanted to hit on, do you guys tap into like OPA and things like that, or is there not a use case for OPA here?
Not yet, no. I'm very interested in it and going to be looking into that, but it's not something that I've really started developing yet. I kind of want to hit the core services and third-party services first, and then start extending and pushing the boundaries of what it's touching.
Yeah, because that'd be interesting. Kind of where Chris was going as well, is that OPA could bring some construct to that. So anyway, I just wanted to ask that real quick. So thank you.
Yeah.
I have a quick question about developer experience. We're talking about the developers here and being able to very awesomely and easily create infrastructure in the cloud, but what about their developer experience locally, like before they're ready to get this thing actually up in the cloud? Is there anything coming down the pipe that's going to help with developers kind of rough sketching this on their own local machine before they actually put this out?
Yeah, so there's a couple of things that I want to talk about. Massimo touched on this one, which is the Docker Compose ECS integration. So what this allows you to do is use Docker Compose locally to define your entire application stack. For example, if you had a sidecar database and then you had your application, you can define all of that locally and just boot up your whole stack locally if you wanted to. And then that also integrates with ECS now. You can deploy this via an ECS provider. We are doing some more work on this. So I think I hinted a little bit in Copilot that that Copilot said you're ready for local development now. So we're doing some work on local development. And one of the things that we have released is ECS. What is it called? ECS local should pop up. Yeah, a guide to locally tested containers with Amazon ECS local endpoints and Docker Compose. So this is interesting because when we talk about what does local development mean, you'll get a lot of different answers. One of the things we've heard from customers, though, is that if they are creating an application that is using, for example, an IAM role, they had some issues trying to figure out, okay, well, how do I make that work when my container is not running on my host, it's not running with my developer credentials, it's running inside a container. And so we've created a experience called Amazon ECS Local Container Endpoints, which allows you to simulate a lot of the things that you would normally interact with in ECS on a production environment. So it will vend a IAM role to your container locally the same way that it would in production. And it will provide the task metadata endpoints to your application the same way that it would in production. And you can even simulate AWS VPC network mode locally. So I highly recommend looking at this. We're going to make
awesome.
this.
That's what I want.
Exactly.
We do use Docker Compose locally for development like that, but we're basically spinning up our own services. Are you saying that I could take a Compose like that and have it give me parity services in Amazon? Like if I'm using Postgres service locally in Compose, I'd get a RDS Postgres in the cloud with that same configuration file? Because right now we basically say there's a local dev file that's Compose, doesn't have anything to do with reality that goes into production.
Yeah, so it doesn't do that part yet. It's more focused on your application right now. So if you had like a local Postgres container, it doesn't have the ability to detect that yet, and then say I'll deploy a matching Postgres in the cloud. So you would have
this role thing, super awesome because
for sure.
That solves a lot of the trickiness because we use roles heavily because obviously it's way simpler than putting credentials all over the place.
Yeah. So we're going to make this more and more baked in, easier to work with. There's a lot more work coming down the line.
2 thumbs up from me.
Yeah, sure thing. Yeah, the developer experience team is top notch. Love working with them, and just keep your eye out for more of this stuff coming from ECS. I think we're running out of time now.
I have a quick question, so it probably won't take very long. I was just wondering that Terraform, people normally see, who are concerned about vendor lock-in, see as Terraform as being this development environment where they can go to any cloud and they're afraid of vendor lock-in, rightly or wrongly. If people go for CDK, do you think that they should be concerned about that, vendor lock-in, or do you think, I know that there's a Terraform driver as well, but still.
Sure. So I think to answer that in terms of CDK lock-in, this CDK application usage is 50 lines here. And if you think about it, this 50 lines shouldn't be too hard to replace in any number of other locations. Like the core thing that's hard to replace is this application. Everything else here is just a description of attach a DynamoDB table to my application and attach auto-scaling roles. And I can define that any number of different ways, whether that's Kubernetes or Terraform. And so I would say that, I wouldn't, as a developer, I wouldn't be too worried about vendor lock-in with this, because even if I decided to throw all of this away, I'd only be throwing away 50 lines of code. And that doesn't seem like it would be a particularly massive effort, ideally. But like you said, in case anyone else is not familiar with this, we do also have CDK Terraform. And this is a great collaboration with HashiCorp on this, which is basically you can use the Terraform as the engine underneath CDK as well, if you want to use that as well. So you have options there in terms of reaching the point. And then also, if you were using this and you decide to stop using CDK, you could always export the resulting template and start managing it yourself free of, so for example here, if I decide to stop using CDK, I could grab all this configuration myself and start using it directly without using CDK at all. I could do the same thing with Terraform. If I was using CDK Terraform to generate Terraform, I could grab the Terraform that was generated out and say, I'm going to assume control over that now and stop using CDK. So there's a lot of pathways to choosing how closely you want to tie yourself to CDK, or if you want an escape hatch, there's always a fairly easy path to escape.
All right, thank you.